From the sources of fresh water in the mountains to the fertile floodplains with rich habitats downstream and the opportunities to navigate to new worlds, river-sea systems have shaped humanity from the very earliest civilizations. Attempts to modify these environments to enhance the benefits or the ecosystem services that they provide have ultimately led to conflicts in upstream and downstream uses. Using examples from the DANUBIUS-RI supersites, we explore how river-sea systems provide provisioning services, including fisheries and waterways, regulating services such as climate, carbon, and water, in addition to cultural services, including a sense of place or for recreation. We start in the city of Hamburg to show how the Elbe was modified for navigation and shipping to ultimately grow the economy to the point where the harbour plays an important trading role in Germany today.
The tidal part of the river has a long history of human influence. Back in the 12th century, the German Emperor Friedrich Barbarossa gave the right to the city of Hamburg to use the waterway for transport and for business. So this was actually the start of the port of Hamburg. And dikes were built already back in the 13th century. So the river stretch is influenced or changed by humans since many, many centuries. And this, of course, comes to a conflict. The human use, the industrial activities and agricultural activities. Today there is the metropolitan region of Hamburg, it's the big port of Hamburg, and there's lots of industry upstream and downstream of Hamburg. Power plants, both nuclear and thermal power plants, metallurgic industry and also chemical industry.
So here we are entering the harbor of Hamburg. It's about 120 kilometers from the sea all the way inland along the estuary. That used to be, of course, an advantage because you could bring all the goods deep inland. Hamburg itself, it grew and grew over time. It's actually the third biggest harbor that we have in Europe. So containers, as you can see, are a very important aspect of the harbor of Hamburg. It's about 9 million containers that are traded and transported each year. And about 1/3 of these containers remains in the area of Hamburg. 2/3 are transported further into the inland. And the added value of these containers is about 20 billion euros for the entire Germany.
The Tay catchment and estuary in Scotland is important for the provision of a range of ecosystem services, from those that help provide food and drink, to those that also help regulate climate and carbon cycling.
Scotland is a true hydro nation, with an abundance of natural water resources as well as a widespread access to clean drinking water. From traditional industries such as farming and fishing, and of course in Scotland the whisky industry, to more recent innovations in renewable wave and hydropower, it is easy to attribute economic value to water resources. However, many of the vital services the river sea systems provide are not always immediately evident, and consequently appreciating and assigning their value can be challenging. Ecosystem services allow us to classify the benefits that people derive from nature. These can be split into 3 categories: provision of services, regulating the environment and climate, and maintaining services and cultural services. The Tay supersite encompasses a plethora of ecosystem services that are vital for the health and well-being of Scotland. Here we have products that come from nature, including food and fuel in agriculture, aquaculture and hydropower. In fact, the Tay catchment has one of the largest concentrations of hydroelectric development in Scotland. We have processes that maintain ecosystems and help manage our environment, such as natural floodplains and vast areas of forest. We also have cultural and recreational services and places of immense historical value, such as the crowning place of the Scottish kings at the famous Stone in Scone. It is essential that we protect our valuable ecosystem services in the Tay supersite and strike a balance between the economic demands on our water environment and the severe consequences of persistent pressures acting upon them. The Tay catchment drains a large proportion of Scotland's upland environment, which is characterised by soils with very high percentages of organic matter. These soils, otherwise known as peatlands, are very important reservoirs of carbon and very important within European contexts as well. The Tay acts as a link between the land and the ocean, and the estuary plays an important role in biogeochemical carbon cycling and the augmentation of greenhouse gases to the atmosphere. With low anthropogenic impact, the relatively pristine Tay estuary is an ideal test site to monitor biogeochemical budgets and better understand the true contribution of estuaries to this cycle.
In the Danube and the Danube Delta, we show how human interference upstream and in the coastal environment have impacted the natural balance of sediment dynamics, which influences ecosystem health and the stability of the Danube Delta itself.
The beaches represent the most dynamic environment worldwide. If you just look at the waves coming up and down the shore face, up and down the beach, you'll see that this tiny motion that takes place a few seconds has been going like this for billions and billions of years. This continuous process took sands, moved them to other parts, shaping practically or sculpting the coasts of our planet. But we need to underline that in the recent history, in the last 200 years mainly, humans started to interfere a lot with this natural phenomenon. How? First, by building dams upstream the rivers, or by making artificial embankments along the rivers, did not allow the water to transport the sands towards the coast. We have now new methods in coastal engineering called soft coastal engineering that try to intervene and to cover up the negative impacts of humans. So it's like helping nature to deal with nature. And these soft protection works, how they are called, they consist of artificially reconstructing beaches or using eco-friendly materials that appear also in nature in a natural way, using vegetation to slow down the dynamics, the mobilization of sands, the coastal erosion. The Danube Delta Biosphere Reserve is the widest area around the globe covered by reeds. Reed beds are extensively developed in this part of the world, and in the recent period, we started to understand more and more the huge natural value of the reed beds. Reeds have excellent roles in biofiltering, in cleaning the water, naturally cleaning the water. They offer shelter to baby fish and other species. And what's extremely important as well, they do play a role in wave attenuation. So they have a natural role in protecting the coasts against erosion. And near us we have this reed bed area in the Razelm Lake, where we have been measuring the way that reeds are cutting down the wave energy, so how the wave energy is dissipated by the reeds. It's an area which is very well monitored and controlled and provide extremely important information that allow us to understand better how nature can deal with nature.
Allowing nature to mitigate against our impacts on the environment presents an important solution. Salt marshes in the Venice Lagoon provide another example of nature-based solutions to promote biodiversity, the functioning of the lagoon, and the protection of the environment.
Behind me, the salt marshes. The salt marshes are normally, as today, out of the sea surface for a few centimeters. During the high tide, they can be completely flooded. So the vegetation which appears here is a very specific one, which can resist from the salt, and it is a very peculiar, very important for the Venice Lagoon biological life. We have a number of species which live here, of fauna inside the mud. The Venice Lagoon is important also for being a nursery of many species of fishes. So it's very delicate to maintain these particular species which are living here, both flora and fauna, because it's a matter of the functioning of the overall lagoon. The salt marshes run the risk to be eroded by the increase of the sea level rise on one side, and also by the physical erosion due to the passage of boats. In the last 100 years, a large erosion, more than 80% of the salt marshes of the Lagoon of Venice disappeared, and some of them has been reconstructed, and in any case there is a morphological plan in order to maintain physically the salt marshes and also with the habitat which is connected to them.
Soft engineering provides an important solution to address the impacts we have on the environment. Another example in the Tay catchment explores the use of one of nature's iconic engineers to regulate water flow and enhance biodiversity in the landscape.
We're here on an estate in Tayside, and this estate was particularly significant because beavers were introduced here back in 2002 as part of a demonstration project in wetland restoration to see what the benefits beavers might bring for restoring water quality and improving biodiversity on streams and agricultural land which had been heavily managed and regulated in the past. The beaver was a key candidate to bring back, partly because it had been a once abundant species in Britain, and partly because of the biodiversity benefits that we know are associated with this keystone species.
What beavers are most well known for is for dams and for felling trees. And the reason they do this is for shelter and for food. So by stabilising the water levels by building dams, their lodge stays underwater, and they eat twigs, and the twigs are located at the tops of trees.
Here's one I prepared earlier. Apart from large trees in the process of being felled like this, we can see really quite high density of dams on what was originally a very, very small stream. This stream behind us was only originally less than a metre wide. Now it's tens of metres wide in places. They make it a much more complex, patchy habitat, and this brings direct benefits for biodiversity, and particularly species like aquatic and wetland plants and aquatic invertebrates.
So what we are really interested in is the impact of the beavers, and we're particularly interested in the way they alter the ecosystem. So beavers are very messy, but that's fantastic for nature, fantastic for biodiversity. But by building these dams, what they act as is big filters, so that any pollutants that may be in the water course come down in the water and are filtered through the dams, and so downstream the water is much more cleaner. But these dams also act as sponges, absorbing water, particularly during floods, which slows the flow of the water and helps in flood alleviation.
Well, I think this is a kind of wonderful example of passive restoration approaches. It's kind of part of what we might think as a rewilding approach. We don't really know what the end point of reintroducing beavers at this site was going to be. There's no kind of scripted outcome. There's no targets, but over 16 years now of working at this site, it's really quite incredible the changes that beavers have brought to this landscape that we couldn't possibly have envisaged when we first started working here back in 2003.
From one of nature's engineers, we explore how we have modified the Thames catchment and over time have improved water quality to deliver critical ecosystem services in London.
Although the Thames super site is impacted in many ways by human activity, it still delivers a wide range of ecosystem services that really underpin the health and well-being of the population of London and further afield. A reliable supply of clean water is a key provisioning service. Indeed, 2/3 of London's drinking water is supplied from the River Thames. Given the high population densities and low annual rainfall in much of the upstream catchment, which in many places is as low as 600 millimetres per year, water supply is a real problem. The amount of available water per head of population is indeed less than in some Mediterranean countries, for example in Israel.
If we had been standing here just over 110, 120 years ago, it would have really been sort of quite an unpleasant experience because the Thames was used as essentially an open sewer. And so we had sort of cesspits, we had open drains that were discharging waste. And in 1858, there was a particular combination of problems that occurred that we remember as the Great Stink. And it was when sewage was passing to and fro in front of the Houses of Parliament behind me, which contributed to such a poor air quality and water quality that people weren't able to enjoy the Thames and had to be very careful because of the noxious fumes that they would have experienced. So as a result of that, an eminent British engineer called Sir Joseph Bazalgette came up with a scheme to design a whole integrated sewer network for London. It consisted of more than 1,000 miles of sewer network that essentially was interconnected with a drainage network in a number of places. The network was designed at a time when the population of London was 2 million. Within 20 years it was 4 million, and at present the population of London is between 7 and 8 million depending upon where you put the boundaries of the city. So when it was originally designed, the intention was it would only discharge 2 or 3 times a year. It's now discharging through what we call combined sewer overflows every week or so. And there's a big new scheme which is currently being constructed in London called the Thames Tideway, which is a £4 billion water infrastructure project to intercept these Victorian combined sewer overflows, to build a series of cofferdams where waters from that combined sewer overflow are taken down to a depth of between 30 and 60 metres, where it can then go on to points of treatment.
Careful catchment management must still play a role to help mitigate against the worst downstream effects of over-exploitation of ecosystem services, such as in agricultural production. We end where the Elbe meets the Wadden Sea, to show how environments can recover and return to a semi-natural state, and maintain critical ecosystem services from which we benefit both directly and indirectly.
So here we are at the end of the estuary of the Elbe and at the beginning of the North Sea. This is what we call the Wadden Sea, and it's a huge stretch of coast going more than 200 kilometers up to the north to Denmark and more than 200 kilometers to the west to Holland. It's shaped by the forces of nature, not only the wind as we experience it right now, but also the tides play a very important role. As you can see, it's now low tide, so we have fast stretches of tidal flats, but in 6 hours or so we will have high tide and I would have got wet feet over here for sure. The Wadden Sea that is actually, geologically speaking, a very, very young area. It's 8,000 years old. All the life that we see over here, these plants, they are special because they are adapting to the forces of nature. They can live with being dry, they can live with being covered with water. and it's not only the plants, but it's also the animals that live here. It's a very, very productive area, and it's because of this that it's now a World Heritage Site. It's the Elbe actually that is carrying a lot of material into the Wadden-Sea. So nutrients used to be a big problem, and actually still there are too many nutrients. But the problem that we had in earlier years were these macroalgae, alpha over here. They used to cover large places, large areas of the Wadden-Sea, and they could grow so fast. They would suffocate the animals living below. They would suffocate also the seagrass. Seagrass would disappear. And what we now see, especially in this northern part of the Wadden-Sea, is that with the decreasing amounts of nutrients that are released to the North Sea, these blooms are also reduced. Seagrass is coming back. Green macroalgae are disappearing, and they are what they used to be in the early days. The big question, a big challenge for the future: what is happening if the sea level rise will go faster because of climate warming? And if the sea level goes faster, then it's an open question whether there will be enough import of sediment, of sand and material that the Wadden-Sea can grow at the same pace. So will it stay like it is at the moment, or will it drown? That's one of the big questions for the future.
Poor river-sea system management has resulted in many conflicting demands and a deterioration of ecosystem functioning. Such anthropogenic impacts are explored further in Lecture 3.